So, the moment we are going to start a new chapter is called wave optics. So, the wave with optics. So, what is wave here? Any wave you can tell. Not you need not go to UV, IR.
Water.
No, that's different. That I will come. That I will come. Wave, simple. You could go for sunlight itself. It's also wave only. That also wave only. Simple. What is electromagnetic spectrum? Electromagnetic spectrum is which involves three various waves of various wavelength. Sunlight, UV light, infrared light. So there are plenty of light is there. In that simple you can take. So a simple one you can take sunlight. So you can take some sunlight, and what you can take, what you can do is I am taking some optics. What is optics here? Mirror. Yeah, mirror or something, some lens, something like that you can take. Some mirror. Okay, you can take some mirror. No, you can take lens itself because it's very small. Mirror is very one big. You can take some small lens. Okay. You can view the sunlight, right? You can view the sunlight. Can you view the sunlight in the naked eye? No, you can't view it. So there itself comes the application. So some object you are putting in between and viewing the sunlight. Okay, but in the naked eye you can't view it. So something is falling on the lens, then it has controlling your eye. So why you can't view directly, and why you can view indirectly like lens. If you view, what will happen?
It causes eye damage.
Yeah, it's a type of infection or something. It's not a type of infection. Your lens will be you can't see it for not more than 1 or 2 minutes. You can see it, but you can't see it for more than 5 minutes or so. Maximum thing you can see is 5 minutes. In contrast, in the lens you can see for a long time, because your lens, there is a lens in your eye will be it will break, it will collapse your eye structure, or your lens will be spoiled. Here the lens is this lens is well protected, so you can view it for 5 minutes. So here comes the application of wave optics. How the wave behaves in presence of lens, in absence of lens. So here comes the main criteria. So in this and you know very well this so this is the main application of things. So in this scenario, now first we go for Eugen principle, right? First is Eugen principle. So in the Eugen principle, in the Eugen principle, the each did I give that definition?
Yes, sir.
What is the definition? The each point of the wave front, each point, did I give the definition? Eugen.
Small stone.
Well, okay, that's no. This main thing. Each point of the wave front is a source of secondary disturbance. Yeah. Did I give that just a definition? I need first this definition. Then we will go for this Eugen principle. Each point of the wave front is the source of secondary disturbance, and the wavelet emanating from this point spread out in all the direction with the speed of wave. This wavelet emanating from the wave fronts are usually referred to as secondary wavelet, and if we draw a common tangent to all this sphere, we obtain a new position of wave front at the later time. Okay, so this is that means did you have this definition? This is the definition, is the source of the everything. This definition forms the source of the entire wave, this entire chapter, because you know very well, I am throwing you can go to lake, visit a lake and throw a stone to it. So it will scatter, suddenly it will fall into the lake. It will scatter for at least thrice, not more than thrice. Twice or thrice it will scatter. Okay, it will scatter and jump into second position, then jump into third position, then fourth position it will get down into the lake. So you can see the ring of wavelets is formed in the each of the things. If it is 3 times scattered, means 3 rings will be formed, and 2 times formed means 2 rings will be formed. So number of number of scatter is equal to number of rings, and the rings will be, you can see number of various rings can be formed. Did you observe? No, you know, right?
Yes.
You have observed that once is scattered in the once is scattered on one portion, then second portion, then third portion. In every one portion you can find plenty of rings. End rings, you will find at least 10 rings. Like that, second ring, third ring, fourth ring. So this is a major basic principle behind the Huygens principle. Then so in the same thing, refraction of the plane wave. Refraction. Refraction of the plane wave. Refraction of the plane wave, I gave the nu1 by lambda 1 is equal to nu 2 by lambda 2. That is when the waves get refracted into a denser medium, nu1 and nu 2 are the two different mediums. Okay, and the wavelength and speed of propagation decreases. That is, they inversely proportional. That is, the frequency of the lambda nu is the medium. Lambda is the wavelength. Yeah, wavelength. So if I take this, if I take in the inverse, what will be now? If I take in the inverse, what will be now? Nu1 into lambda 2 is equal to nu 2 into lambda 1. Okay. So now how? So now nu 1 is directly proportional to the lambda 1, and nu 2 is directly proportional to the lambda 2. So did you understand this point?
Yes, sir.
How I got it?
Inverse.
Inverse, just cross multiplication. Not inverse, cross multiplication. Nu1 divided by lambda 1 is equal to nu 2 divided by lambda 2. So I am taking the lambda to the upper portion. So it will be nu1 lambda 2 equal to nu 2 lambda 1. So now you can, if you remove, nu1 lambda 2 equal to nu 2 lambda 1. So lambda 1 is equal to lambda 1. Lambda 1 is directly proportional to the nu1 directly proportional to the lambda 1. So nu 2 is if you keep the nu 2 and lambda 2 as 1. Assume that nu 2 and lambda 2 is 1. Now what will happen? Nu 2 lambda 2 as 1. What will happen? If you substitute 1, what will happen? Nu 2 by lambda 2 1. What will happen? No, nu 2 by nu 2 1 lambda 2 1. What will happen? 1 by 1. 1 divided by 1. So 1 divided by 1 is equal to what? Nu 1 is equal to lambda 1. So nu 1 is equal to lambda 1 means nu 1 directly proportional to lambda 1. What is nu?
Nu is a medium.
Medium. So that medium is directly proportional to the wavelength. So if it is stronger means wavelength will be lesser. If it is higher means wavelength will be stronger. Okay. Now say in the similar trend we go for rarer medium. Can I give rarer medium?
Rarer medium.
Yeah. What is the equation I give? Sin IC is equal to
N2 by N1.
yeah N2 by N1. Then Doppler effect. After this Doppler effect, no?
Yes.
So what is a Doppler effect?
Time taken between the arrival of two successive wavefront is longer at the observer than the source. Thus, when
Yeah. So when the observer length is longer, then it says then when the source moves away from the observer, the frequency as measured by the source will be smaller. This is known as Doppler effect, and it is given by delta nu divided by nu is equal to minus nu radial by c. That is what nu radial is the component source of velocity about line joining. Can I give this?
Yes,
Velocity to the line joining the observer to the source relative to the observer, and nu radial is considered as a positive when the source moves away from the observer. So the Doppler effect. So Doppler effect is defined as, so when that is the two sources is there. That is, one is they approaching the two trains are there. Two trains are there. First possibility is they are moving at the same direction. Another possibility is they are moving in the opposite direction. Okay.
one is same direction, another one is
Opposite direction. Two trains you take. They are moving at the same direction. Another one they are moving at the opposite direction. Okay, keep it as A, B. A and B are moving at the same direction. A and B are moving in the opposite direction. Then another is A is faster than B. They are moving in the same direction, but they are moving at the different speed. That means A speed is different. A speed is greater than B. That means A will move faster because speed is faster than B. So it's whatever the so in this case the time taken between the arrival of two source, time taken to arrive a successive friend is longer at the observer than its source. That is, so when the source move away from the observer, the frequency as measured by the source will be smaller. So that means the frequency measured will be smaller. So that's frequency only given by nu, delta nu by nu is equal to minus nu radial divided by C. What is delta nu?
Nu divided by nu, sir.
Delta nu by nu. What is a delta nu by nu? Delta nu.
Change in frequency.
Change in the frequency. Nu radial is
Component source.
component source, correct. Component C is the speed of light.
Speed of light.
See, constant or speed of light you can put. C is okay. Then is coherent and incoherent addition of wave. Okay, the superposition principle, according to the particular point of medium, the resultant displacement produced by number of wave is a sum of, is a vector sum of displacement produced by the each waves. Okay, so and it is given by I is equal to 4
I0.
for I, not I0,
I naught.
I naught.
I naught.
I naught means what is I naught? What is I and why? What is I naught?
I is indivisible intensity of the wave.
I naught is
Sorry, sir. I naught is indivisible intensity of the wave.
uh,
Then
I is the total intensity.
total.
Total intensity of all the waves. I0 is the individual intensity. Individual. For example, there are 10 waves is there. 10 wave is there. Okay. I0 is the individual intensity, means first one, then second one, third one, fourth one, fifth one. I is total intensity. Total intensity is equal to sum of all the waves. So if there is 10 means it should be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Like that you have to calculate for 100, for 1000, etc. That's all. I is equal to total intensity. Then Young's next, what is that? Next one, Young's experiment, no? Inference of light wave or Young's experiment? Inference of
Any experiment, sir?
Young's experiment. Young's experiment. Inference of light.
Spell that, sir.
Inference of light wave or Young's experiment. Y-O-U-N-G. Y-O-U-N-G. Young's experiment. Okay. So the Young's what is the Young's experiment is that the light
Inference of light wave.
no wait the inference of light wave
Two sodium lab
Uh.
penetrating in the presence of two
okay
pinhole.
Oh, okay, phone. So then it is given by, that is when the light source is passed through a silt, when light source is passed to a silt, you can see the various fringes. Okay, what it does that fringes. Okay, you can see the once the light is gloomed, once light is gloomed, it can pass various waves. Okay, so what he did, he has taken only one silt. That means only one silt he took. He passed the light towards that one silt or one hole or silt, anything. Silt means a hole is there. No, you can close that hole via silt. How you water can is there? Just you can open it. It is open now. But you can, if it is closed, it means it is closed. So you can open the. So if it is closed, means what? The light will not pass to its that. Light will not pass to the No, no, no. See, I am telling the example. This and this is not well related. I am taking, say, now it is closed or what?
Pinhole.
Huh?
Pinhole.
Pinhole, pinhole. Because I am open, now it is closed or open?
Closed.
Closed. How it is closed? Via lid. La, it's a type of lid. Silt is nothing but a type of lid. Silt is nothing but type of lid. So, if it is open means, if open, closed means closed. If it is open means, if it is open means light will pass through the source. Light will pass through that pinhole. If it is closed means, it is not, light will not pass through it. So, if light passed means, the light will have a various electromagnetic waves. There will be plenty of electromagnetic waves. So, if you pass through one silt, what he observed, he observed the fringes. Okay, fringes. What is fringes? A type of ring-like structure. Yeah, a type of ring-like structure. Fringe. What is fringe means? It's a type of ring-like structure. Various rings he observed. Something around 10 rings. Something around 10 rings. You can take some 10 rings. So he observed. Yeah, this is the source of light. Source of light is there. Silt is there. And then in the wall, you can assume the distance now. Distance is not a big issue. I am telling how the experiment he made. I am saying like this. This is source of light where I am here. There's a silt. Silt means it will allow. It's a only pin size pinhole. The hole will be like almost pin size, not very much big. Pinhole or pen size, not more than that. When the silt is opened, immediately he observed fringes. Fringes means ring-like structure. Almost 10 ring-like structures he observed. So what could be this? Then he concluded that the light source when it's narrowed down in the same thing when the same thing the entire cab is when it's closed, he can't observe that fringes. So three experiment now. First is open the silt, close the silt, then remove the silt. Remove the silt. Remove means that entire silt is removed. Now the source is here, their wall is there. He observed. He could not observe that fringes. Just a light passed on it. That's all. Okay. Yes. See now three experiment. First he didn't keep any silt, nothing. Just he kept the light and observe the wall. He saw that light is falling on the wall. No, is there no fringes, nothing. Now he set up the experiment. Cardboard, something cardboard. In that cardboard, he made only one pin like a hole. Okay. Then he observed it. Fringes. Fringes means ring-like structure. He has saw it. Then again, what he did, he closed the third experiment. The third experiment, what he did, he closed the pinhole. He closed the pinhole. Now what he observed, he could not see any fringes. That's all. So the three experiments he performed. Then he came to know the light wave, the light which is falling, the light will have a various wave. Light will once light source from the source of light, you will be getting various waves. Plenty of wave is there. If you are able to narrow down only one wave, you will get a fringes. So that then he observed that. So you have to narrow how many. So the fringes is due to presence of how many waves?
10 fringes, one wave.
One wave. You have to narrow down that wave. So if you are able to narrow down the wave, you will get you will observe a fringes. But what is it in the first experiment?
Nothing came, only wave.
There is no experiment setup at all. Just a source of light is there. Then just he observed the wall.
Light is just falling.
Just light is falling on it. That's all. Nothing is observed. So because why nothing is observed there?
Narrow. On the setup pinhole which is setup color.
No, yeah, the first experiment, no pinhole, nothing. No cardboard, nothing. That is experiment number 2. Experiment number 3, experiment 2, 3, 1, 2, 3. Just source of light is there, wall is there. Okay? No cardboard, nothing. He can't observe no fringes, no inference, not fringes, inference. Inference of the wave you could not observe, nothing. inference of the wave is he didn't observe. Now experiment number 2, he kept one cardboard and placed one hole. Now he observed the inference, not fringes, inference. Fringes is the ring size. Fringes is a ring size. Inference of the wave he observed, which that is inference of wave nothing but ring-like structure. Some 10 rings of the 10 rings he observed. Then in experiment, he went to experiment 3. What is experiment 3 now? Close the lid. When he closed the lid, he observed he saw in the wall, nothing, he didn't see anything. No light is passed. So it's very dark. Nothing. He could not observe that inference. Okay. Now, why he observed in experiment 2, experiment 3 you leave it. We don't want experiment number 3. Experiment 1 and 2. In experiment 1 itself he could have observed. Now, why in experiment 2 only he observed it?
The source is passed through the pinhole. So
In where? In experiment number?
1, 2.
In experiment number 1, it is the source of the light, and light is passed particularly to a pinhole. Then so you will observe he observed the inference. Inference means 10 rings. 10 rings you can keep. 10 rings you can keep. Now in experiment 1 he could not observe. That's my question. I am asking that question. Why he could not he observed only in experiment 2, not in experiment number 1.
Experiment 1, the light traveled straightly, sir. Second experiment, light traveled through the pinhole.
Everywhere light travels straight only. Everywhere, both experiment 1, 2, 3, everywhere light will travel. Wherever the light it will travel straight. There is no definition like light will dominate. It can able to bend everything. That's different. So that difference, that is not the answer. I am asking you. I asked you clearly. In experiment 1, he observed in the wall. In the wall, he observed only light as only. He observed only light, flashlight only. But in experiment 2 only, he took the cardboard, narrowed down the whole pin. He put that whole size pin size hole. Then he observed a fringes of the inference of the wave, inference of the light. So that is called inference of the light. So he observed only in experiment 2. That's my question. My question is that he is observed in experiment 2, but in experiment 1 he could not observe. Why it is?
Your object is kept middle.
Huh?
Your object is kept middle.
Object is?
Kept middle. The cardboard is there.
Yeah, cardboard is kept. If you keep cardboard, will you get inference?
No, sir.
He put a pinhole, not a big hole, pinhole. So what it did know, when he put the pinhole, the light, he has narrowed down the wave, narrowed down the wave. That means only one wave entered. One wave entered, it showed the inference. Here, in experimental 1, the cardboard is there. No, he removed the cardboard, nothing is there. Just many waves traveled. So many wave, one wave. One wave, or in other words, narrow downing the wave. So if you narrow down the wave, you will observe the inference. So this is what Young's confirmed. So beta is equal to
Lambda d by d.
lambda d by d. What is beta?
Fringe width.
Fringe width. What is lambda?
Distance of the fringe from the source.
No, lambda.
Lambda is wavelength.
Wavelength. Lambda is wavelength. What is d? Big D, small d?
Big D is distance of the fringe from the source. Small d is distance between the two fringes.
Two fringes. Next is diffraction. Okay.
Yes, sir.
Yeah, when the it seems the diffraction experiment, diffraction definition I gave. Diffraction definition.
The inference of the wave by which it is scattered in different angles is
It's a different angle. It's called diffraction. Okay, then you can see that geometry theta is equal to lambda by a, no? Theta is equal to lambda a by a. Theta is the angle of scattering, lambda is the wavelength, a is the what?
Distance between two waves.
Distance between the two waves, correct. Then what is it then in huh?
Minimum distance equal to 1.22 lambda.
Lambda by resolving the minimum distance, lambda r0 minimum distance is equal to 1.22 lambda f by or 0.61 0.61 lambda f by a. Yeah, it's written 0.61 0.61, like that's same only 1.22. Okay, you take that itself now, otherwise 1.22
2 lambda by 2n sin beta.
Correct. dn is equal to 1.22 lambda divided by 2n sin theta. That is what? If it is what is it? Resolving power of the this is a minimum distance. That is, I want to see the optical for the optical instrument. For any object, if you take any object if you take, I want to view the thing. If it is so, what will be the what is lambda? What is d minimum?
1.2.
No, d minimum. What is the definition for d minimum? D minimum.
Minimum distance.
Minimum distance. That is a minimum distance between the image and the lens. Then lambda,
Wavelength.
wavelength. Beta n,
N is
refractive index. Beta is
angle subtended by the lens at the focus of the
at the focus of the things. That is, any if you want to keep this if you want to view the thing, if you want to view the image, any image, so the minimum distance that it should be there is a d minima. Then lambda is the wavelength that light used. Then n is the refractive index of the medium. Beta is the angle scattered. Then polarization. Then polarization. So the polarization is a 1. Polarization is a 1. If you assume that polarization is the, that is, if you light, for example, polarized light versus sunlight. What is the difference between sunlight and polarized light? Sunlight falling from on earth. So it has a various electromagnetic wave spectrum. Like sunlight falling source of the light, it has UV light, it has infrared light, it has various light of the things. Polarized light means only polarized. Polarized means
It can be traveled all the direction rapidly.
it can travel. Polarization.
One direction.
Traveling only one direction. Here means sun is there. Okay, sun is there and earth is also there. Earth is rotating around the sun. Okay, so earth is rotating sun means sunlight is rotating to January also. So January, so 365 days. What is how many year it will take to complete one entire Earth's surface? 365 days it will take to complete the one rotation of the sun. So that 365 will be divided into 12 months. That means it will get light. It will get light in the January also. It will get light in the June also. It will get light in the December also. So all that every time you will get the light. So because the light will be you will get uniform light. But so how it is rotating now? How it is rotating? All planets are rotating in the elliptical pathway. That's very, very important. That's why we are getting two things. Summer will start in the month of May, by which you can see that it will be very hot. very hot. Then you go for winter, which is October. If you go for October, you will see that rain will be heavy. October, November, the 2 months rain will be heavy. This April, May summer season, the sunlight will be very, very heavy. So the temperature, what will be the temperature of the earth now, surface temperature?
30 or 40.
No, 40. Earth temperature, not India temperature. India is 30. If you take around the world, it will be 40. Because sun is falling, earth distance to the sun is very, earth distance to the sun at this point at the summer will be very less. So the temperature that falls on the is very high, so temperature will be high. If you go for in the month of October, November, the distance is very less, so the rainfall, the temperature will fall down. So polarization. So polarization, where you can see that light will be traveled in all the direction. Sun, if you take sun, say in all the direction, but I am taking one polarized light. Light means it will fall on the only one direction. Polarized means the light will fall on the one direction. Any axis you can take. You can take as a preferably x axis. X axis means it will follow only on x axis. Then y axis and z axis. What happened to y axis and z axis?
There's no light.
No light. Light will not fall. So it's given by lambda is equal to
Lam-
no
mu
Mu equal to sin IB by sin.
for polarization. Nu is equal to nu is equal to
Sin IB
by
sin R
sin I by sin R
equal to sin IB by
sin pi by 2 minus
I by IT. Okay. So IT, and this is sin nu is equal to sin IB by sin R. So C is equal to sin IB by sin pi by 2 minus IB, and this is nothing but Brewster's law. Brewster's law.
Yes, sir.
Yeah, over. Thank you. Huh? Yeah, can you intimate them?